Thank you for that, Matt. Okay, so we're on question number 4. We have a roof drain that runs 52.3 meters horizontally. So this is from here to here, 52.3 meters. Or is that, oh, wait. To avoid an obstruction, okay, it goes to here. There's my 52.3 meters is from here to here. And then runs another 33.8 meters from there to there. Now, if the grade on the first part of the piping is 1.041% and 1.1% on the second part, what is the total drop from point A to point C? So we also have this little drop in here. It says it drops 0.845 meters right here. So we have to add that to at some point to get that drop in there. Okay, so let's do the grade on the first one. So 52.3 meters. And my grade on that first pipe says it's 1.041. So that's 0.01041. So let's do that. 52.3 times 0.01041. And that is 0.544 meters is the first drop. And then we're going to add the 0.845 meters to that. And now let's get this grade for this one here. So that's 33.8 meters multiplied by that grade, which is 1.1% on the second part. So that's 0.011. And that comes out to 0.3718 meters. So I'll add 0.3718 meters to this, and we'll add those three together. And I come up with a total drop of 1.76 meters. Is my total drop for question 4.
Doug, would you mind just going through that again just once more?
Sure. So let me just clarify here. I will use a different color for that. So we have our first spacing in between A and B at 52.3 meters. We did the grade for 52.3 meters at 1.041%. And that's where I got that from here. And I got my total drop for this piece of pipe right there.
Okay.
Secondly, I had a drop right here.
Sorry, I'm just
Sorry, go ahead.
How did you get that 0.0? How did you get the 0.01041 measurement?
Okay, that's a percentage, right? Before I multiply by a percentage, I must divide by 100 to get it a decimal. Because it is a percentage, I must reduce it down into a decimal point. And so that becomes 0.01041. Similarly, I did that with this percentage as well. The 1.1%, 1.1, and I have to divide it by 100 to get it as a decimal before I multiply. And then that becomes that right here. Now, the second portion, or wait, the drop over here, sorry, this little drop is right there. That's 0.845, which says it right in here. And then I have a run of 33.8 meters at the 1.1%, which is this equation. And then I added all of these three drops together to get a total drop of 1.76.
Okay, perfect. I don't know if anybody else wants this, but when you go through equations, could you go through it again? Because I think some of us are trying to write it down as we're going and having a hard time trying to pay attention to it.
Well, that's a great point. Yes. Okay.
Totally.
Well, let's start with number 5 here. We have a pipe that runs 532 feet. That is our run, and it drops 2.5 feet. We want to know the grade to the nearest 1/16 of an inch. Our formula triangle will say take your drop, 2.5 feet, and divide it by your run, which is 532 feet. And that should equal my grade. 2.5 divided by 532. And that's going to come out to 0.00499 feet. Now they want it to the nearest 16th of an inch. So this is in feet. I got to convert that to inches. I will multiply by 12 inches per foot. And then that comes out to 0.0563 inches. But they want it to the nearest 16th. So I am going to take this decimal of an inch and multiply it by my denominator. And that would give me my numerator, and that comes out to 0.9. So that comes up to 1. So there is my grade, 1/16 of an inch for every foot.
Sorry, Doug, when I punch in 2.5 divided by 532, I get 4.69. Is that?
Me too.
Oh,
Yeah, same here.
does it have a minus
Minus-
to the
Minus
0.03?
0.03 at the end.
Yes, so hit on your calculator mode, the mode button, and then the number 9.
Okay. Yeah, but it's still 0.0064 or 0.004699.
Oh, I might be a little off with my.
But yeah, that makes sense for the zero part. Do you have to
Okay.
do that every time there's minus zeros, you have to hit mode?
Well, what it's telling you is how many decimal places it is. You're right. That should be a 6. Thank
Hey,
you
Doug.
for that. Yeah.
I did it a different way, but I got the same answer.
Okay, Henry, listen, you can cross multiply, you can do all kinds of things. I have no problem with doing it a different way if we get the same.
Okay.
Okay.
Okay. Okay.
All right, this next question, number 6 here, is going by this same picture that is on figure 3. So we're going to say this piping configuration in figure 3 runs at 1 grade throughout its horizontal. So it says that it's going to run 1 particular grade throughout its horizontal distance. Okay, now we have the distance between A and B being 34.3 meters. That's the distance between here and here. And the distance between B and C is 24.6 meters. This vertical drop right here, this vertical drop is 350 millimeters. And now the total fall of the system is 750. So the total drop is 750 over this entire run. So we want to know the percentage of grade. Now, this grade will not include the 350 millimeter drop. That is not a part of our grade. So we must minus that from the 750 mils. And that clearly gives me a 400 millimeter drop over this entire run. So I will add those two runs together. So that's 34.3 meters plus 24.6. I must be a little dyslexic this morning. That's 9, 8, and 5 meters. There's my total run. And this is my total drop. So the formula triangle will say I take my drop or rise and divide it by my run. But we have a problem here. We have two dissimilar increments of measure. So I will have to convert one to the other. And what I'll do is I'll take 400 mils and I'll divide it by 1,000 millimeters per meter to get 0.4 meters. So I will change my 400 mils to 0.4 meters. And then I can get that grade. So 0.4 divided by 58.9. And that equals 0.00679. Now I have to multiply it by 100 because they want this as a percent. And that comes out to 0.679% is my grade.
Hey Doug, I came in like 2 minutes late. What was that about? Pressing mode and 9 or some shit?
That's if you have this number here. So this one would be 6.79, and then up in the corner it would be minus 0.3, meaning there's 1, 2, 3 decimals here. This right here is the minus 0.3. So if you hit mode and the number 9, it will convert it back.
Gotcha.
Okay.
Brett, I asked you to do it. Could you go over it again?
The same question? Okay. I will just use a different color to highlight what I did here. So this question, number 6, is referring to this picture up here, figure 3. So we have the first run right here is 34.3 meters. And that's where they say this is right here. They said they had the second run, 24.6 meters right here. And they had a vertical drop, this point right here, of 350 mils. That's where that came in. So this vertical drop right in here does not go to my grade. This is a vertical drop. It's not a part of the grade. So the total vertical fall of the system was 750 mils. So I had to take that little vertical drop off of the entire fall of the system to get my drop for my pipe at 400. I converted that 400 mils to 0.4 meters. The formula triangle for grade is the drop divided by the run is equal to the grade. So I took my total drop, 0.4 meters, divided it by my run, and I got my grade. But they wanted it expressed as a percent, so I multiplied that by 100 to give me my percentage. Does that answer the question? Hopefully.
I think so.
Okay, I think we should do a few more grade questions here. Okay, so I'm just going to do a few more grade questions over here, and I'm going to write them out, and I'm going to give you a moment to work on it yourself. So I have a pipe that runs 120 feet. It is graded at 1/8 of an inch per foot. What is the drop? And remember this formula triangle where the drop is equal to the run times the grade. Did everybody get 15 inches?
I'm not done yet, so I can tell you.
So 1 divided by 8 is equal to 0.125.
Yeah, that was where I was when you asked the answer.
Okay.
Is the grade always going to be in inches?
No, not always. It could be expressed as a percentage, as a ratio. It could be in millimeters compared to meters. It could be in, yeah. Okay, so
I think for this question, the feet would cancel out. That's why it becomes inches.
that is absolutely correct. The feet get canceled out and I'm left with inches. Okay, let's do, I'm going to write down another one. So we have a run of pipe. I'm going to say 80 feet. And I have a grade at 1/4 inch per foot. What is my drop?
$20.
How much?
20 inches.
20
20
inches.
inch.
20 inches, yes. So what we do is we take our run, 80 feet, and multiply it by 0.25 inches per foot. Comes out to 20 inches. Let's do another one. I have a run of 17 meters with a drop of 34 millimeters of. What is the grade as a percent?
Uh, 2%.
No. It's close.
0.2.
0.2%. So in this question, we are having two dissimilar increments of measure. So it says take your drop and divide it by your run to get your grade. So 0.034 meters. So 34 millimeters divided by 1,000 millimeters per meter is equal to 0.34 meters. Oh, 0.34 meters. And now I could take that and divide it by 17 meters. And that comes out to 0.002. And if I times that by 100 to make it a percent, it's 0.2%. Okay, one more. I have a pipe that's 33 feet, 8¼ inches long. Here's my run. This is graded at 1.5%. How much does it drop? And I want it to the nearest 16th of an inch. Put your answer in the chat.
Was that 33 feet and 8¼ drop run?
Yeah, 8¼ inches, Matt.
Yeah.
Okay. So take a few minutes, do this. Put your answer in the chat. So here is the issue with this question. This has two dissimilar increments of measure. And when we're dealing with a percentage and we have to multiply by a percentage, I cannot have two dissimilar increments of measure. So I'm going to convert everything to inches. So 33 feet times 12 inches per foot is equal to 396 inches. And then I add the 8.25, that's the 8¼ inches to that. So my total run is 404.25 inches. Now I can multiply that by my grade. My grade says 1.5%, but I have to divide that by 100 first, 0.015 before I multiply that, 0.015. And that comes out to about 6.069 inches or something close to that. So that's 6 inches. And then I want it to the nearest 16th, 0.069 times 16th is 1/116th. Good. Do we need any more examples on grade?
We do one more.
You bet. I'll do one more question here. You have a,
Doug, sorry to cut you off there.
no, go ahead.
When I was looking at the formula triangles, it just says percent grade times the run gets your drop. There's nothing on there about converting that to 100. Is that just the general rule though? If it's percent
It's the
grade?
general rule. If it's a percentage in here, we must convert it to a decimal before we multiply it. Okay.
Okay, yeah, that makes sense.
Okay.
Oh, I see there's a note on there on the triangle. Never mind, thank you.
You're welcome. Okay, I have a run of 28.5 meters. Okay, it is graded with a ratio of 1:50. I want to know what is the drop. Take a minute and put your answer in the chat. There's number 2. At least I didn't record that. I don't even know how I stopped recording. So anyways, number 2, we start out by removing the 200 mils from our line, and it's 3 meters per hanger maximum spacing. 40.4 meters divided by 3 meters is 13.466 spaces. That rounds up to 14, and we add 1 to make 15 hangers. Excellent.
Lovely, Grant.
So let's look at number 3 here. If the hangers in figure 6 are spaced 8 feet apart, how many are needed? So we have a 1 foot spacing up here. We have a 3 foot spacing here to the first hanger, and we have a 2 foot spacing there from the last hanger. So our overall run is 86 feet. We need to minus off the 1 foot. We need to minus off the 3 foot, and we need to minus off the 2 foot. So that comes out to 80 feet. Does everybody see where I got 80 feet on there?
So our overall is 86, and you're just taking off the hangers that they already have in place.
Well, no, we're taking off the spacing here. So there's 1 foot spacing here, 3 foot between the first hanger and 2 foot before the last hanger. So we're taking off those spaces where we won't have hangers. So now they're spaced 8 feet apart. We come out to 10 spaces or 10 hangers, and we always add 1, 11 hangers. Not too bad. To objective 3. So this is where we're starting back out, objective 3. It says in here that we're going to calculate vertical distances in both metric and imperial values using, and then they use some words here, geodetic, abbreviated geodetic, and you could call this modified geodetic and architectural elevations. So elevations. An elevation is a vertical measurement, and it's the difference between these two are called elevations. And they're related to each other through a fixed elevation, and we want to know the distance in between those points, okay? And this is critical, man. This is critical for proper placement of pipe and fixtures and systems and a lot of different things. So this is why this is important. And in this year, we decided to add a lot of stuff on elevations. So we start off by saying using a building level. Now we're going to go through an entire ILM on builders levels, what they are and how to use them, how to fill in forms. We're going to do all of that stuff. Okay, but this is where we start out. So to properly calculate these elevations, we use this tool. And what we do is we start from a benchmark. Okay, a benchmark is a known elevation. So we have to start off from somewhere which is known. Sometimes they're called a datum point. All kinds of words are used to have this benchmark or a known elevation. All right, because sometimes your builder's level has to be moved because we may have things in the way that we can't see some of our things. So when this happens, accuracy and readings become very important when you move that particular tool around the job site. We want to always start at a benchmark or a known elevation. Now, geodetic elevations. Geodetic is sea level as a reference. So geodetic is starting at sea level. As you can see, 0. Oh, look at Calgary. Calgary says we are 3,400 feet above sea level. Calgary is considered high altitude, if you did not know that. I think I said that once. And look, as you go north, you start to go downhill. What is the difference between elevation between Calgary and Edmonton?
378 meters.
Sure, or about 1,200 feet. So you're actually going downhill as you drive north. Does anybody know what the elevation of Fort McMurray is?
4,000 something.
Fort Mac is about 600 feet above sea level. So as the more you go north in this province, you are actually going downhill. So that's just an aside note, if you didn't know that. So anyways, then we get to something that's called modified geodetic. Geodetic is used starting from sea level going upwards. Modified or abbreviated is when you have a benchmark. So this is your geodetic benchmark of 632,310 millimeters above sea level. To modify this elevation, they simply take that 6 off. And now look, it's modified. That's all they are doing, is dropping the big numbers to make it a little easier to calculate elevations. We can modify this elevation even more by taking off the 3. And as you can see, we have 2310 millimeters. Look at this down in here. So it's just modified. That's all it is. It's just taking off the extra big numbers. So it cuts down on mistakes in calculation because there's
So-
fewer digits. Go ahead.
So couldn't you just zero it down from 0? Like if your modified geodetic measurement, wouldn't you just start from the ground essentially from your lowest point?
Now, then you're talking about a benchmark.
Oh, okay.
Okay, so that's a little different because prints and especially bigger prints, etc. If you have a big plot plan, you're going to have some modified geodetic or maybe even geodetic elevations on it, right? And then from there, we can determine a benchmark.
Okay. Thank you.
Or we can do what's called an architectural elevation. So an architectural elevation is actually a given benchmark or a fixed object, right? And I think that's what you were trying to get at.
Yes. Thank you.
Okay. So you can see here, we have a benchmark on this print. It's up here and it gives you a geodetic elevation, right? And then some of these other ones are given modified geodetic elevations because they don't have the extra number up top. So these are modified numbers. They're modified geodetic elevations on here. And this is the elevations of the roads. Okay, is what it is. And then it kind of gives you an elevation of a overhang of a roof, etc. But that's all this is talking about, is just the modified one. Now, the architectural elevation, it's a fixed object. And most normally it's the main subfloor, or sometimes they call it top of subfloor. On a print, you can sometimes see this abbreviation. It means top of subfloor. And so this architectural elevation is a given number, and sometimes it's 10 or 100 meters or 100 feet. So it gives you a top of a subfloor and it'll say 10 meters, TOSF. This way, if we go down underground in the basement to run our pipe, we're not using negative numbers. We don't want to use negative numbers when we're doing elevations. So that's why the architectural elevation is given, and there will always be greater than 0 on this. So for example, it says in here, an elevation of the subfloor in figure 9, oh, we don't have figure 9 yet, has been valued this 10. Let's look at figure 9.
Hey Doug, quick question.
Yes,
For the subfloor, would that just be like the lowest like slab? So if the building had like a parking garage, would it be in the parking garage?
No, it would be on the main floor in the foyer.
So then if pipes are in parking garage or below that, then we would be stuck going with negative numbers.
Yes, so we don't have negative numbers. So in this picture, as you can see right here, top of subfloor, they give you 10 meters. For bigger buildings, they would give an architectural elevation of probably 100 meters. So as we go down below grade, if I had 3 meters down to this point from the top of subfloor, my elevation here would be 97 meters, yes, at this point. You see how that works?
Yeah, makes sense.
Okay.
Yeah.
So we won't have, so this one is actually, if it's 3 meters less, And if this is 10 meters, then this is going to be 7 meters as an elevation down here. Okay, we just don't want to work with negative numbers. So this is the top of the subfloor, and this is our architectural elevation at 10 meters. Now, everything below it, if we had to shoot, so this right here is ground level. As you can see, this is ground. This is the symbol for dirt right here, or earth. And this is the ground. So I want you to calculate the elevation at the ground level right here. Using some math, figure out how far we go down to get the elevation right here on the ground. Your prints are all in millimeters. These are millimeters, millimeters, millimeters. All the numbers on your print are in millimeters. So can anybody tell me what my ground level is?
2.65 meters down. So I guess, oh shit.
Yeah, see, now you're getting it. So we have 250 mils there. Let me just get a pen here. 250 mils right here. And then we have 2.4 meters. So 2,400 mils with this distance here. So that is a total of how much? 22,650 millimeters. And then I'd simply take my 10 meters minus 2,650. And you are correct, 7.35 meters or 7,350 mils. That is correct. So this elevation right here at ground level, my elevation is 7.35 meters there. Okay, so it's simple addition and subtraction. If you're going up, you add. If you're going down, you subtract from your elevation benchmark or architectural elevation or your datum points. Does that make sense to everybody? We are going to calculate these elevations in this figure. So we have geodetic, we had modified, and we have architectural. As you can see, here's our benchmark or our known elevation. So, and now we have geodetic, modified, and architectural. This is our known elevations right here. These are the known elevations. Now, everything is either added or subtracted from these numbers. So let's look at A number 1 right up here. So we're going to come from 587.842 and we're going to go up 1.2 meters, 750 mils, and 1.05 meters. What would A in the geodetic elevation be? These are meters. These are meters. And these are meters. So 587.842, we add 1.2, we add 0.75, we add 1.05. A is 590.842. Yes? And now we're going to take the 1.5 off. And then we're gonna add this, and B would be 589.792. And then C, we're gonna take the 0.75 off. We're only gonna go 1.2 meters up. And then that's gonna be 589.042. Modified, they're just going to be the same numbers, only taking the 5 off. So this is going to be 90.842. This is going to be 89.792. This is going to be 89.042. Now, architectural, we'll just add. This is going to be 101.2. We're going to add 0.75 to that. So this is going to be 101.9. 5 meters. And then this one up here, it's going to be 103 meters. Close to it. Does everybody understand how that works?